Camera Tracker is a dynamic, reactive, three-dimensional camera system for virtual environments. Our relationship to any virtual environment is framed by our perspective into it. This perspective is mediated by an in-game camera. How a camera frames an environment, the information it chooses to show or exclude, and the efficiency and clarity with which it presents that information can have a dramatic impact on how the player understands and interacts with that environment, and on the perceived difficulty of a game. When modern video game technology moved from 2 dimensions to 3, the methods for controlling a camera became much more complicated. Instead of simply scrolling from left to right or up and down, the camera suddenly had to navigate complex geometric environments, avoid running into obstacles, and provide players with a perspective that was both engaging and helpful. The challenges of manipulating a 3D camera have been made especially apparent in third-person platforming games. Games that fall within this genre typically require players to run, climb, and fight their way through a series of increasingly difficult navigational obstacles in order to succeed. The standard approach to camera within this genre is a third-person, over-the-shoulder, floating viewpoint. The camera either follows at a fixed distance behind the player, or moves along a predetermined path. Though this system works fairly well within most environments, there is still room to improve. Typical problems encountered by this camera include improperly framing the environment, accurately portraying depth for the player, and accidental occlusion of the player's avatar or of important objects in the scene. Current systems also neglect to take into account the performance of the player within the game and instead offer the same fixed perspective no matter how much that perspective is or isn't helping the player succeed. This is where Camera Tracker, our reactive three-dimensional camera, steps in. Camera Tracker uses player performance as the agent for controlling an in-game camera. If a player seems to be having difficulty in a certain section, Camera Tracker gives them a new perspective. This system was developed in Unity 3D. The virtual environment was created from scratch in order to test the camera system within a variety of common platforming situations. 3 different levels were created, which each feature a range of different jumping challenges. For this environment, 6 different camera techniques were implemented, though the potential for different camera styles is limitless. The techniques chosen were a tracking perspective, which points at all times in the direction where the player must go next. 2 orthogonal perspectives, horizontal and top-down, that frame the environment as if it were 2-dimensional. These cameras were one attempted approach to solving the problem of depth perception, converting a measurement of depth into the screen into one of on-screen X and Y distance. A picture-in-picture camera, which places an additional perspective into the world in the bottom right corner of the screen, and indicates to the player where the next important objective is. A hold-to-focus camera, which allows players to press a button and zoom in to the next important element in the scene. And a transparency manager, which tries to prevent occlusion of the player by making objects between the camera and the player transparent. Though these camera techniques have been used before, Camera Tracker helps by recording how well any one perspective is working for a player, and changes perspectives based on which is the most ideal for the player's current situation. Cameras are selected like this. First, a group of nodes are placed in the world that hold information about what camera perspectives are available in their area. A tracking system monitors the player's position in the world and their current success in each area of the game. Player failure is recorded and reported to the camera manager. The information about player success or failure is retained and stored in an aggregate database of information about player performance on each node. The camera manager then uses the past history of every playthrough to decide which of the in-game camera perspectives to use. This history is aggregated across all players and stored in an XML database. Cameras which have historically shown more success with players are more likely to be selected by the manager. The manager then activates one of the in-game cameras. At any time, the player can press a button and switch to another perspective. This is also recorded, allowing player preference to have an impact on future camera selection in addition to player performance. Here you can see how the camera manager chose different perspectives after 5 playthroughs. Player successes, deaths, and camera preferences have caused some nodes to default to other camera perspectives. Camera Tracker is both a system for dynamic game alteration and a tool for game designers. Designers can get quick feedback on whether or not an in-game camera is helping a player progress through their game. By adding multiple perspectives, the system can move towards what is the optimal perspective for each element of the game. Furthermore, the system could be used to adapt camera perspective to player skill. Experienced gamers could be given a more standard sequence of camera profiles, while novice players could be guided through a level by the framing and positioning of the camera. Camera Tracker offers a new perspective into the world of dynamic 3D cameras.